All right, in this video, we're just revising the index laws. You would have covered these in year 10, but we'll just review them because you're overwhelmed with a lot of information and you may have forgotten them. So the key ideas should definitely go into your bound reference. You can see all the index laws there. Basically, here the letter A represents the base. So we call the number, whatever we're taking the power to, the base. Okay, so here A is the base and M is the power. A is the base and N is the power. And you can see in law 4 and 5, we've got two different bases there. Instead of actually going through these key ideas, and I'm not going to go through the examples, I'm just going to go through the questions. So in your bound reference, with whatever questions you don't understand, it's a good idea to actually write them in your bound reference as examples so you can refer to them at a later stage. All right, let me just, so we've got all times here. Times are easy. Okay, so when you are multiplying, always write your base first. Okay, so here we've got the base, that is A, and we add our powers. So I'm not going to write 5 times 4, 5 plus 4, because we know 5 plus 4 is 9, so it's just A to the power of 9. For D, slightly different because we do have coefficients, okay, the 7 and the 2, so we can multiply them first, which is 14, and then we write the base, and then we write the power. Just don't get confused with 2 and 3. 2 plus 3 is 5. Don't go ahead and write 6. There aren't really any, maybe the fraction one here at H. Remember when you're multiplying fractions, so I might just do that first. And then what have we got? C to the power of 7. When you're multiplying fractions, you just multiply the numerator, so the top number. So 1 times 2 is 2, and then on the bottom we have 12, C, 7. And 2/12 is 1, 6, C7. And usually we write that with the C7 at the top and the 6 on the bottom. Okay, so just remember 1 6 times C to the power of 7 is the same as C to the power of 7 on 6. All right, let's move on. All right, with these extension type ones, we just look at the, you can see we've got different bases here. Okay, so let's skip the easy one and just go to O because they always have the harder ones at the end, and what's the point of doing the easy ones with you? So let's look at the coefficients first, any numbers. We've got a 4, that's a 1 there, and a 5. So 4 times 5 is 20. Let's just get the pen. Okay, so we're doing this one here, 20. Then we'll look at the M's. Now you can write this all out in one go, but I think by year 10 you should be able to skip that step. So we've got 6 here. If it's easier, put the 1. Okay, so that's M to the power of 1 and N to the power of 1, and that's an M to the power of 1 there. So how many M's? There's 6, 7, 8, and then N is 7, 8, 9, 10. Okay, so don't forget those bases. If there's no power written there, it's just the number 1, and you can't forget that one. Okay, so sometimes it's easier actually just to write it in so you don't forget to add it. All right, let's move on to the next one. All right, so if you wanted to pause here and then do those questions, you can, or you can just keep watching, it's up to you. All right, so here we are dividing. Now when you're dividing, it's pretty easy as well, just write the base. But this time we're subtracting our powers. So 5 minus 2 is 3. Now, if you want to see that, so some students just take these rules for granted and not understanding why. Okay, so I probably should have chosen a smaller one. What have we got? 1, 2, 3, 4, 5, 6. Oh, and x's. So I've got x times x, and it looks like I've got a bunch of x's. Okay, so we've got 5 x's on the top. Okay, so that's what x to the power of 5 looks like. And then on the bottom, we've got x squared. X times x is x squared. And you know they cancel out. So any number over another number is just 1. So this x and this x cancel out because they just equal 1. And then this x and this x cancel out. So what are we left with? 1, 2, 3, x to the power of 3. Looking at question E, I always prefer to write division like this. And if you're moving into methods, you would probably do all your division like this. Is you can easily see, all right, our base is y, and then we just subtract the power. So 8 minus 3 is 5. When I look at I immediately just think, oh, I would much prefer it written as a fraction, okay? Because then I can see what to cancel out. It's kind of, instead of writing it linear when it's horizontal on top of each other, it's easier to see what we cancel. So this x cancels out with one of these x's, just makes that 1. So we've got 2xy cubed. Now there are solutions in this worksheet, so you can always check your answers. Now this extension is quite tricky. I think the first 3 I would rewrite like the rest of them. It is just so much easier to see what is being cancelled out. Okay, so let's look at R. All right, so we've got numbers in here now, so coefficients. So let's have a look at the negative 8 over 16 first. So you've got to think, all right, think of this as a fraction. So if this was a fraction, what's the highest common factor? It's 8. So this is the same as a half, yeah? So I can rewrite this whole fraction, and you don't have to do it in so many steps as this, as negative, we don't write that one, x squared y cubed over, and then is because we simplified it, we have now the 2 on the bottom, x squared y. So I've just looked at the negative 8 and the 16 for now, and I'm leaving all the pronumerals. All right, so let's now look at the pronumerals. So I have x squared here and x squared, so they do cancel out. That's awesome. Just leave that negative. That negative doesn't get cancelled unless there was a negative on the bottom. All right, and then this y cancels out one of these y's, so that becomes 2. So we're left with negative y squared on, what are we left with on the bottom? 2. So it's just a matter when you have it as a fraction, it's a lot easier to see, all right, what is cancelled out. And you're probably thinking, what if we have a negative indice up here? That is something that we will cover. But at this stage, you should always have positive indices. Even if you had negative indices, I think at this stage you can just leave them as a negative and wait till we review that topic. All right, now we have powers to the power. So when you have powers to the power, it's just multiplied. So 5 times 2 is 10. So we have x to the power of 10. Let's look at I. Actually, let's look at C first. Oh, no, not C. Where have we got one? Okay, E. Just because we've got a number in, a coefficient in the brackets. So it's also 4 cubed. Okay, so whatever is in the brackets gets cubed. So the 4 is cubed and also the t is cubed. So 2 times 3 is 6. Now you should know what 4 cubed is. Maybe not off the top of your head, but you can easily work it out. 4 times 4 is 16. So then we do 16 times 4. And you can either do it, I would do this 10 times 4 plus 6 times 4, which is 40, 64. Or you can just do it the long way, how you would do it in primary school, which is exactly what I just did here. Okay. So what do we get? 64 T6. Okay, so with just before we move on, with these powers, you'll never get anything that you can't, or that you're not expected to work out. So we wouldn't expect you to work out, let's say, 9 to the power of 4. Okay, but we would expect you to do 2 to the power of 5. Okay, so 2 to the power of 5, you should be able to do 2 multiplied by itself 5 times, but yeah, we wouldn't expect you to do something that high at this stage. Okay, so let's look at perhaps I before we move on. Okay, so here we have a squared, and that's squared. So we have a to the power of 4, and then the b is also to the power of 2. So 3 times 2 is 6. That is a b. Okay, so just remember anything inside the brackets is taken to that power. All right, for your extension, okay, I think you should be able to cope with that. Let's just do the very last one, p. So everything inside is taken to the power of 4. Oh, 4 to the power of 4. Maybe you can use your calculator for that one. 4 to the power of 4. P, 2 times 4 is 8. Q, 3 times 4 is 12. 3 to the power of 4. And then R to the power of 4. I don't know what 4 to the power of 4 is off the top of my head. You can just do that on your calculator. And then 3 to the power of 4 will probably cancel out at some stage. You can have a look at your solution to do that. But I do want to move on. Otherwise, this video is going to be very, very long. All right. Anything to the power of 0 is just 1. Okay, so just think of these as 1, not 0, but 1. So this is 8 times 1, which is 8. Let's skip to the harder one. So 7 times 1 is just 7. This whole thing is 1 because it's to the power of 0, so it's minus 4 equals 3. Okay, what have we got here? The answers. Okay, so just reviewing the index laws. Have a go at doing most of the questions or maybe every second question. I'm just going back to see which index laws weren't covered because I don't think they all were. So we did that one. I think we did them all. Yeah, good stuff. Okay, so that's just reviewing the index laws, stuff that you would have covered in year 9. When we return next term, we'll do a little bit more revision of it, but we'll also be looking at negative indices and fractional indices, and they're extremely important if you are heading into methods. All right, thank you.